Friday Bytes by Helixz.
I'm Shehan, and today I will explain how Kubernetes architecture works. So, most of us use already containers in development, and they are lightweight and portable, easy to run web. But when it comes to running containers in production across multiple machines, things become very complex quickly. Kubernetes is the system that slow that complexity. It take individual containers and organize them into clusters, making them scalable, manageable, and reasonable. So in this session, I will break down how Kubernetes is structured generally and how its main components work together. So what is Kubernetes? Kubernetes is an open source system for managing containerized applications. It automates deployment, scalings, and operations. Instead of manually running containers on different machines and trying to manage them all, Kubernetes handle that orchestration. You can think of it as a control system that makes sure containers are running where they should be, in the number they should be, and it's in a healthy state. That's the core idea behind Kubernetes. So why we need Kubernetes? Uh, when application grow, managing containers manually become difficult. If a container crashes, someone has to restart. If traffic increases, someone has to scale it. If deployment fails, rolling back become risky. This create problem like failing deployments, configuration resource constraints, and scaling bottlenecks. And of course, human error become as a big risk. Kubernetes solve those problems through orchestration. If provides self-healing, meaning of a if a container crash, it's restart automatically. If provide auto scaling based on demand, and it handle load balancing across instance, and it supports rolling updates without downtime. Instead of manual operations, everything becomes automated and declarative. You define the desired state, and Kubernetes makes sure the system stay in that state. Uh, what is a Kubernetes cluster? Kubernetes doesn't run on a single machine. It's run as a cluster. A Kubernetes cluster is simply a group of machines working together to run containerized application. Each machine in the cluster called a node. There are two main types of nodes: master nodes, also known as a control plane, and worker nodes. The master node is responsible for managing cluster. The worker nodes are responsible for actual running the applications. So you can think of it's like the master node make decisions, worker node execute those decisions. Let's look at the master node. So this is the master node, also known as the control plane. You can think of it as the brain of the entire cluster. It's actually not running on your application, and instead it's making decisions. It decide where code should run, keep track of what's happening in the cluster, and make sure everything stay in the state we define. If something crash, it's it's dead. If something missing, it regets it. If we send a command, it processes it. The control plane is made up of four main components: the API server, CD, and scheduler, the control manager. Each one has a specific job, and together they manage the whole system. Let's start with the API server. So the API server is basically the front of door of Kubernetes cluster. Everything goes through it. When we run a command using kubelet, when Someone use the dashboard UI or internal components to talk to each other. Communication path through the API server. It receive request, validate it, and update the cluster state. For example, if I say create a pod, that request first hits the API server, then it store the information in its CD and notify other components. So you can think of the API server as the central hub that connect users, the control plane, and worker nodes. Now, once the API server receives store everything, where does actually data actually live? That's where it's CD coming. So CD is basically a database of Kubernetes cluster. It's distributed key value store that's keep all the cluster data. Whatever the API server receive, or details, what configuration, deployment information, secrets, everything gets stored in state. It's store both current state and desired state of the cluster. For example, if we want three replicas of a pod, that desired configuration is saved in each CD, and all the control plane component rely on this data to make decisions. If each CD goes down, the cluster basically loses its memory. So it's one of the most critical components. Now, once the data is stored, someone has to decide where pod should actually run. That's the scheduler. So the scheduler is responsible for deciding where a pod should run. When a new pod create, it doesn't immediately go to worker. It first stay in pending state. The scheduler look at available worker nodes and choose the most suitable one. Uh, how it decide uh, it it's check the things like CPU and memory availability, node labels, container toleration, and affinity rules. So it's not random. It's evaluate the cluster and place pod on the best possible node. Once it make decision, the pod gets assigned to specific worker node. Now, placing a pod is one part, but what if something crashed or doesn't match the desired state? That's where the control manager comes. So the control manager is the component that constantly watch the cluster. Its job is simple: compare the current state with desired state and fix anything that doesn't match. For example, if we said we want three replicas for a pod, but one crash. Now only two are running. The controller manager detect that difference and create a new pod to bring it back to three. If there are extra pod running, it's removed. If something deleted or accidentally, it regates it. So basically, it's running continuous monitoring loop, observe the current state, compare it with desired state, store in its TD, and take action if needed. That's how Kubernetes main scalably automated. So that cover the control plane. Now let's move a worker node is a machine that actually runs our application. This can be physical server or virtual machine. When the control plane assign put to a node, this is where it's run. The worker node, we have a few important components: the kubelet, kubeproxy, and container runtime. The node also manage resources like CPU, memory, and storage, and handle networking for the pod running on it. So, in simple terms, control plane decides, the worker node executes. So let's break down kubelet. Kubelet is an agent that run every node worker node. Its main job is to communicate with the control plane and make sure containers are running as they should. When the control plane tell a node to start a pod, kubelet pick up instruction and starts the container, monitoring the health and report back to the API server. So you can think of kubelet as the node's local manager. It makes sure everything is assigned to that node actually happen and stay running. Uh, Next up on the second one's kubelet. Kubeproxy runs on every worker and take care of network. Its job is to make sure both can communicate with each other and with service inside the cluster. It implements service networking, load balance traffic, and maintain the rules that allow requests to reach the right port. Basically, kube proxy is what connects everything running on the node to the rest of cluster. The so traffic flow correctly and reliably. Now that we covered networking, let's talk about actual unit running applications. Pods and container runtime. So what actually run on the worker node? That's the pod. The pod is the smallest deployment unit in Kubernetes. It can contain one or more containers that need run together. Each pod has its own IP address and can share storage between containers inside it. Pods are infrequent meaning they can be destroyed and recreated at any time. Pod always run on worker nodes and they what actually execute application inside the cluster. So inside the pod, container are actually run by the container runtime. The runtime is engine that pull container image, create containers, and start the processes, apply resource limits, command runtime like the container. So basically, the container runtime is what makes the pod actually execute application code. Without it, pod it is just like a definition. Nothing would actually run. So let's work through how Kubernetes handle pod deployment. First, the user send the request. For example, I want to run this pod. The request goes to the API server. The API server stored the desired state in CD. The scheduler look at the cluster and decide which worker node should run the pod. The controller manager makes sure everything is in desired state. On the chosen worker node, Kubernetes receive the instructions and start the container using the container runtime. Meanwhile, kubeproxy set up networking so the pod can communicate. Finally, the system enters a monitoring loop to ensure the pod stay healthy. So basically, from from the moment you request a pod to it running and begin monitored. A component work together automatically, and that's the basically the full cycle of Kubernetes deploy and manage workloads. So we went to the Kubernetes architecture, how the control plane and work nodes works, and how get for deployment and manage. So thanks for your time.